Hi everyone, this is a video that involves thermal properties and we are just solving problems related to change in temperature only for this question. So the question given is, what is the final temperature of the mixture if 100 grams of water at 70 degrees Celsius is added to 200 grams of cold water at 10 degrees Celsius and well stirred? So this is what we know so far. The 70 degrees Celsius water will be cooled down by the 10 degrees Celsius water. Or we also can say the 10 degrees Celsius water will be heated up by the 70 degrees Celsius water. Now you look at the numbers here, we know that the temperature has to lie between 10 degrees Celsius and 70 degrees Celsius. Why is it important to take note of such things? Because if your final temperature is more than 70 or less than 10, please relook again. So another way, we also can say that the 70 degrees Celsius water supplies the heat and the 10 degrees Celsius water gain the heat from the system. Since the final temperature is somewhere between 10 and 70 degrees Celsius, we will not arrive at the melting point or boiling point of water. Therefore, we are not concerned with specific latent heat of vaporization or fusion. Up to this point, we just let T be the final temperature of water. So change in temperature for the cold water should be T minus 10. Since cold water's temperature is supposed to rise and the temperature of hot water is supposed to drop, hence the change in temperature for 70 degrees water should be 70 minus T. Now questions like this, there's a lot of numbers involved. It can be quite painful in an exam condition. So first things first, we lay out the data in a very structured way. Why so? So that we can solve the question more easily later. It may take time to write down this data, but this investment is worth it because it allows you to focus on problem solving instead of you figuring out which number fits into which part of the equation. So for a start, let T be the final temperature reached. And in a given space, I'll just allocate one space and divide it into two parts, where one part is the heat supply and the other part is the heat gain. So let's talk about the heat supply first. The heat supply has to be a 70 degrees water. So its mass is 100 grams. We don't know its specific capacity. And the final temperature, and the change in theta 1 is 70 minus T. Now for the heat gain, it will be the cold water, so it's 200 grams. The C2 is also unknown, and the change in theta 2 equals T minus 10. Now once we lay it out, the solution becomes much clearer. Since both substances are water, C1 equals C2. Never mind the value is unknown, just form the equation first. So we're going to use the principle of conservation of energy, and that is heat supplied by 100 grams of water equals heat gained by 200 grams of water. Once we form this, M1 C1 change in theta 1 equals M2 C2 change in theta 2. Substitute in the values, you realize that C1 cancels itself out in two sides of the equation. Again, this is a physics lesson, this is not a math lesson. I'm not going to show you how to manipulate this equation to get a value of T. You do it yourself. The value of T should be 30 degrees Celsius.